Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Subject is matrices and calculus. Today, we are going to discuss the topic on the double integration and also the triple integration. Under the double and triple integration, that means here the double is nothing but the two integrations, the triple integration is nothing but the three integrations. In previous lectures, we discussed about on the double integration and again the triple integration individually topics. That means under the double integration, the limits are constants, the limits are variable. If sometimes the limits are not given, how to find the limits and how to find the solutions. And again, the limits are under the double integration, the polar coordinates. Sometimes they change the order of integration. These are the some of the methods we discussed in the previous lectures. And again, moreover, we discuss under the triple integration, the limits are given the constants, the limits are the variable, and equations are given how to find the limits, then how to find the solutions. That clearly we discussed in the previous lectures. Now, today we are going to discuss again the double and triple integration. That means the concept is under the two integrations, under the three integrations. Here, how to find the solutions with respect to like the constant limits, the variables, polar coordinates, then area bounded by the region, and again change the order of integration, and triple integration, the constant limits, and again the variable, then how to find the solution in briefly like. For example, under the double integration by direct integrations. And what is the meaning of this? That means whenever the limits are like whenever the integrations are the two integrations, the limits are given the constants, then how to find the solutions. Here, for example, what is a double? The double is nothing but the integrals of a function of two variables over the region r square are called simply it is called as a double integrations. And based upon that, for example, the double integral of a function of two variables, that means the two integrations are with respect to the variables are x comma y, that is under the given function over the region in r square, it is a double integration. That means, for example, the double integration, the region is that is a f of x comma y under the region two integrations, and again that here the variables are xy is nothing but dx dy, and sometimes in branch of dy dx. That means whenever the double integrations, the limits are given how to find the solution under the constant limits. That is a first topic. Here the double integration with constant limits. For example, here the limits are under the double integration a to b, c to d. The function is f of x comma y into dx dy. That means here the limits are not given particularly for these are the constants for x and y. We need to assume any order, but we need to give the priority. Here the inner is the x given function dx. That means we need to assume that inner limits are for it is a x is equal to c to d, and again after that simplification we need to do that with respect to dy. That means we need to give the priority for inner to outer, that whatever the limits are given that inner limits are, it is treated as x is equal to c to upper limit is d, that rest of the terms that y is equal to a to b, and again with respect to dy. That means we need to find with respect to x and after with respect to y. For example, that under the double integrations, here the function is under the f is a function of x comma y. The limits are same a to b and c to d, but here dy and dx. While we are going to observing here, the inner variable is with respect to y, that is a dy. That means we need to consider here y is equal to c to d is the limits with respect to dy. After that simplification, we need to integrate it with respect to dx. This is the meaning of we need to give consider whenever the limits are constants, if they are not mentioned here inside to that outside. The inside is a inner limit with respect is a dx, that is a treated as x, and outer is a y, that is a dy. That means y is equal to limits. And here finally the conclusion of here it is a the conclusion of that xy. Note that the process of evolution is iterative. That means the first evaluate the integral with respect to dx, and then after with respect to dy in case of order of integration dx dy. That means dx is given first inside, we need to integrate it with respect to x, and after with respect to y. And similarly, for example, it is a vice reverse for the integration dy dx. The meaning of here, it is a, inside is a dy that we integrating with respect to y, and after with respect to x. This is the meaning of here. The process is reverse for the order integration dy dx. Whenever the limits are not mentioned that particularly like x and y, we need to follow that inner to outer. For example, we discuss some three problems. Here, the double integration 0 to 1, 1 to 2, xy into dy dx. That means here the problem is under the function x comma y, that is a dx with respect to dy. The limits are not mentioned that particularly like x and y, but based upon the understanding here, the inner is a dy. That means we need to treat it as these are the limits for y is equal to 1 to 2, and rest of the limits x is equal to 0 to 1. And based upon y is equal to 1 to 2, while we are integrating that x is a constant, that y integrating is a y square by 2, and the limits are in between 1 to 2. Therefore, after applying like upper and lower in the y, that is the solution is 2 minus 1 into x, that is a x in that integration 0 to 1, that x into dx is the value after replacement of 1 to 2, that is upper is a 2 and lower it is a 1 value. And further it is a x integration, that x into dx is nothing but it is a x square by 2. That x square by 2, again the upper limit is 1, the lower limit is 0. Therefore, here also after that simplification, that is a 3 by 2 into x square by 2, the limits are 0 to 1. That is 3 by 4, it is 1 minus 0. The solution is 3 by 4 is a final solution. Therefore, this is a simple understanding. Whenever the limits are constants, it is not given the particularly like x and y. We need to assume like based upon that inner to outer and find the solution. And for example, here the problem is 1 to a, 1 to b, dy dx by xy. And here the formula problem under the xy is a function, variable is xy, integrating dy dx. First we need to give the priority for y is equal to 1 to b as per the concept of here, and rest of the limits are x is equal to 1 to a. Now, while we are going to integrating, first you need to assume that is I is the part, and again integrating with respect to y. That means 1 by x is the constant, that 1 by y is the integration, that is a log y. Therefore, based upon the integration, this is the log y. While we are going to replace that upper and lower, it is a log b minus log 1. And as we know that the value of log 1 is equal to 0. That means that is the value of 1 by x into that is a log b minus log 1. And this value is a 0 as we know that the value. And again here log b take out common, and integration that is a 1 to a, that is a log 1 by x into dx. And again the integrating 1 by x is the value is a log x. And in between the limits are that is a 1 to a. And similarly, here also log b take out common, it is a log x, and the limits are 1 to a at x is equal to. Therefore, here also log b and log a, and minus log 1, the value of log 1 is 0. Therefore, the value is a log b into that is a log a. This is also one example for that, easy to understand how to find the double integration under the limits are constants. For example, integration 0 to a and 0 to b, x plus y into dx dy. And here also the function is clearly under the xy variable. and again that constant limits, and here also first the inner it is x, therefore we need to assume that x is equal to 0 to b and y is equal to 0 to a. Now again we need to integrating first with respect to x. That integrating with respect to x is nothing but the first term is x. The integration of x is equal to that is x square by 2. But here place that here the variable is a y. But integrating with respect to x, here the function variable is y. Therefore, we need to take out common y is outside. The remaining term is a 1. Therefore, as per that rule, here let us assume that I, and again integrating first with respect to here it is x. Therefore, x square by 2 plus y into 1 is nothing but it is a yx. Therefore, it is x square by 2 plus yx. The limits are in between x is equal to 0 to b. Therefore, after replacement at x is equal to that upper limit is b and lower limit is 0. Therefore, it is a b square by 2 plus that is a by minus lower limit is totally 0. And here once again integration 0 to a, that is a b square by 2 plus by into dy. Now again we need to do that with respect to y. Therefore, here it is a b square by 2 is a constant, that is a b square by 2 into 1 is a, with respect to 1 y is a b square by 2 into y plus b is a constant. That integrating y is nothing but y square by 2. The limits are y is equal to that is 0 to a. Now again we need to replace that y is equal to a. Therefore, here lower limit is 0. Therefore, by replacement of upper limit, the value is ab square by 2 plus a square b by 2. Here, if we need to take out common ab by 2, the value is a plus b is a final solution. That means after the simplification like this, we obtain ab into a plus b by 2 is a final solution. And similarly, for example, integration 0 to 1, 0 to 1, 1 by under root of 1 minus x square into 1 minus y square into dx dy. And here also the function is under the double integrations. The variables are with respect to x and y. The limits are not mentioned that particularly, but we need to assume that inner to outer. The inner is nothing but we treat it as x is equal to 0 to 1 and the outer is a y is equal to 0 to 1. And based upon here it is a first we need to assume that I. Therefore, here while we are going to do that with respect to inside, that is with respect to x. That inside of that with respect to x is nothing but it is a integration 1 by root of 1 minus x square. The integration is sine inverse x. Therefore, while we are going to do that, it is a according to that inverse integration dx by root of a square minus x square is a that is a sine inverse of x by a is a value. But based upon this one, it is also a is 1 and x is as usual x. Therefore, sine inverse x is the value. And again, the upper limit is that is 1 and lower limit is a 0. And here, replace that x equal to 1 means that is a sine inverse 1 minus sine inverse 0. That means after replacement of sine inverse 1 minus sine inverse that is 0. And here, sine inverse 1 is nothing but as we know that the values that is a sine of it is a pi by 2 minus sine inverse of that is a sine 0 and sine inverse of sine theta is nothing but that is a theta. Therefore, pi by 2 minus sine inverse of sine theta again it is a value is 0 and based upon here it is a pi by 2 minus 0 is a value. And here we need to take out common again pi by 2 outside, integration 0 to 1 by root of 1 minus y square into dy. Therefore, again by using that whatever you know the formula sine inverse y and again here pi by 2 into one more it is also sine inverse y. The limits are 0 to 1. Therefore, sine pi by 2 into sine inverse upper limit is a sine inverse that is 1 minus sine inverse 0 and it is also pi by 2 into the sine inverse 1. That means again similarly in the above one and here also that is sine inverse of sine theta, but theta is equal to once again it is one more pi by 2. Therefore, pi by 2 into pi by 2 is the value is a pi square by 4 is a final solution. That is a value of pi square by 4. And similarly, for example, evaluate integration 1 to 2 and 1 to 3 xy square into dx dy. And here also the function is under the double integrations. variables are x comma y. Here the limits are constants, the inner to outer. Because of it is also not given that particularly these are the limits, not any mention. Therefore x is equal to 1 to 3 and y is equal to 1 to 2. And based upon this one, we need to assume that first I, and after that we need to integrate it with respect to first is a x. The x integration is a x square by 2, and again here the limits are it is a 1 to 3. Therefore, after replacement of upper and lower, that is a 9 minus 1 by 2, that is a 8 by 2. That 8 by 2 is also nothing but 4 by 4 into integration 0 to 1 to 2 and y square by 2 into y square into dy. And once again we need to do that integrating with respect to y. And here also 2 into 4, it is a cancel, that is a 4. Y square integration is that is a y cube by 3. The limits are that is a 1 2, that is a 2 value. Now again we need to take out common 4 by 3 is outside. The 2 cube is nothing but it is 8 minus y cube is nothing but 1 cube is a 1. Therefore that is 28 by 3 is the final required solution. Therefore this is the procedures like under the variables are like double integration. The variables are like x comma y with respect to, but the limits are constants within the problem. And similarly other concept, that means whenever under the double integrations, the variable limits are given, then how to find the solutions. Up to here, we discuss under the double integration, the limits are constants, then how to find the solutions. And we understood properly. Now we'll go to discuss that is under the double integrations, the limits are not at all constants, the limits are variables. Then what is the procedure to find the solutions? For example, we need to understand the concept. Here, the double integration with the variable limits. And while we are going to observing this one, here depend upon the two cases here occur. That means under the x comma y variable, sometimes the variable in terms of x. That means it is treated as y. We need to integrate it with respect to y. Sometimes the limits are in terms of x. That is treated as y. Then we need to find with respect to x integration. Then that is the procedure under the double integration. The variables are given. That is the meaning of when y1 comma y2 are the functions of x and x1 comma x2 are constants. That means under the x comma y, the limits are y1, y2 are in terms of x. That means it is treated as y, then after with respect to x. And see that is the meaning of first integrating with respect to y, keeping x between the limits y1 and y2. And then the result expression in the x with respect to and after with respect to x next to. That means, for example, we need to understand. Here, this is the double integration. That is a function f of x comma y. That is a dx dy. While we are going to observing here, based upon this concept here, the limits are in terms of x. That we need to assume that these are the limits for y. That means integrating with respect to dy. And after simplification, this one, then you need to integrating with respect to that is a dx. And this is the one of the important to understand whenever the limits are given the variable. For example, sometimes the limits are not in terms of x. The limits are in terms of y. And what is the meaning of that? For example, the function is under the xy with respect to dx dy. That means the inner limits are in terms of y. The inner limits in terms of y. That we need to assume that x. That means integrating with respect to dx. And after that simplification of this with respect to dx, then we need to further with respect to dy. These are the very important to understand whenever the double integration under the variables are x comma y, then how to find the solutions. And here, for example, the limits are 0 to 2 and 0 to x, y into dy dx. And what is the meaning of this? And here, the problem is not at all under the constants. The limits are in terms of variable. And which variable? That means while we are observing here, the limits are under in terms of x. That means based upon the concept of here, we need to assume that first y is equal to 0 to x, and after that we need to do that integrating with respect to x is equal to 0 to 2. Therefore, we need to consider it is also I first with respect to y. That means y integration is a y square by 2. Therefore, integrating replace that upper limit is a x and again the lower limit is a 0. And after replacement of here y is equal to x, that is a after take out common 1 by 2, it is x square minus 0, that is nothing but x square into dx. Now again we need to do that with respect to x. That means here after that simplification here, it is a 1 by 2, that x cube by 3. The limits are in between 0 to 2. And here it is a 1 by 2 into 1 by 3, that is 1 by 6. The upper limit is 2 cube, that means 8 minus lower limit is 0, that is 4 by 3 is the final solution. That is the meaning of here. Whenever the limits are under the variable, that we need to do that according to based upon this understanding. Now, for example, here the problem is 0 to 5, 0 to x square, x into x square plus y square into dx dy. And here also the problem is not at all based on the constant limits. The problem is based upon the variables. Under which variable is given here. Here given that in limits are in terms of x. That means we need to integrating, we consider y is equal to 0 to x square, and again the rest of the term is x is equal to 0 to 5. But while we are going to observe here, before going to discuss here, we need to understand one more point also. When we are treated as y, that means we need to integrate in with respect to first is a dy. But the problem is given, it is a dx dy. That means we need to interchange first is a dy and interchange that is a dx. After changing that with respect to dy dx, then further we need to find the integrations with respect to dy. Therefore, after modification like that dx to dy, then we need to integrate with respect to y because of the limits are in terms of x. Due to that reason, we interchange the order of the dx dy is equal to dy dx. Therefore, now again we need to do that integrating with respect to y first. Therefore, x into x square is x cube, but with respect to y is the integration 1 is a with respect to y is a x cube into y plus x into that is a y square is nothing but x into y cube by 3. The limits are 0 to x square. Now again by replacement of upper and lower with respect to x square, here you obtain that upper and lower, we obtain that one because of the lower limit is 0. Now again here x cube into x square, that means x power 5 plus x into x square whole cube, that means x power of 7. That means x power of 5 plus x power of 7 by 3. That means here integrating with respect to x is nothing but after multiplication x cube into x square is x power 5. Again integrating is a x power 6 by that is a 6 plus here 1 by 3 constant. Here x into x square whole cube, that means x power 7 by 3. Therefore 1 by 3 take out common. X power 7 integration is that is a x power that is 8 by that is a 8. And now again we need to replace that x is equal to 0 to that is x is equal to 5. And after replacement of upper and lower, we obtain that clearly the solution will be 5 power 6 by 6 plus 5 power 8 by 24 is a final required solution. These are the some different type of the problems whenever the limits are under the variables are given, how to choose that particularly the limits and again how to find the solutions. Now further integration 0 to a and 0 to root of a square minus x square into dx dy. And here also some examples we discuss in the previous session also, but we need to observe that how to do that and again how to find the solutions. For example, and here also root of a square minus x square is a formula based upon sine that is a x by 2 root of a square minus x square plus a square by 2 sine inverse of x by a, and here also of 2 clear by replacement of upper and lower, and based upon sine inverse 1 is nothing but it is a pi by 2 and remaining the lower term is sin inverse 0 is the value is 0. Therefore, that is a proper. And similarly, for example, here also the limits are under the x that we treated as y is equal to minus x to x, and again x is equal to, these are the limits. For example, we need to watch it like, for example, here also based upon the integrating one by one, that clearly we obtain by using the formulas, by using the upper and lower, and here also the final solution is 13 by 120. For example, here also the limits are under the two variables, and moreover the limits are with respect to x and y, but the inner variables are in terms of x, that we need to assume that dy and dx. But here we need to understand first y and after x. That means the given problem is not in proper position, that is a dx and dy, but we need to interchange dy to dx, and after modification dy and dx, then we need to find the solutions first with respect to y, and again after with respect to x. For example, here integration is, and again by replacement of upper and lower, then the term will be, and one more further integration with respect to x, then the problem is x power 4 by 8 plus x power 7 by 2 into 3 into 7 by 2 minus 5 by 6 and x power 5 by 6, 0 to 1. Here the solution is finally 3 power 56, and here also some different type of the problem under 0 to 1, 0 to root of 1 minus x 1 plus x square, and dy dx by 1 plus x square plus y square. Here, while we are going to observe here, it is different, like that treated as a first is a y, and again after that x, they given the proper order. But here the formula is based upon the integration of 1 by 1 plus x square into dx. That means it is a square plus x square formula 1 by a into tan inverse of x by a, and here a is equal to 1, but here a is equal to 1 plus x square, and a square is the treated as integration d 1 by root of 1 plus x square of 4 square plus y square, and with respect to dy we need to do that according to like this, and here 1 by a is the 1 by root of 1 plus x square, and tan inverse of y is the y by root of 1 plus x square, because of a is equal to root of this one, and y x is equal to y is the formula, and based upon this is the formula we need to replace, like it is clearly based upon the formula what I mentioned already, same like that. Here once again we need to remember the tan inverse one. The tan inverse one is nothing but it is a tan pi by 4, because of tan 1 is a tan pi by 4 only, and based upon the values we obtain that pi by 4, and in other formula that sin h inverse of x by a also, based upon that any one of the formula we need to give the property pi by 4 log of 1 plus 2. For example, third concept. What is the third concept? That means whenever the double integrations are in the Cartesian coordinates, here area enclosed by the plane curves. What is the meaning of this? That means what we discuss now, it is the limits are constants. How to find the solution we understood. The limits are under the variable, then how to find the solutions we understood properly. Now our concept is further, the limits are not given, then how to find the solutions. That means sometimes the equations are given in the format. By solving the equations, by using the diagram, we need to find out the region And after finding the region, then find the limits and find the solutions with respect to either the parallel to x-axis or parallel to y-axis. That means we need to understand what is the concept of the parallel to y-axis or parallel to x-axis or division of the region, and what is the meaning of this one. We need to understand properly. Here, whenever the problem is procedure to find the double integral over the region, that is R, we need to follow that some certain steps. What are the following steps? Here, first draw all the curves and identify the region bounded. That means they are giving the equations, then we need to draw the diagram. That is the meaning of draw the curve and identify the required region. That means where it is a bounded region. That is the meaning of the required region is nothing but from the given equations while we are solving that, we need to get the diagram. In that, we need to identify what is a bounded region in between the region. And next one, find the points intersection of all the curves if it is required. That means if you get the roughly sketch, we need to find out what about the intersection of the points from the given bounded region. And third one, take the step parallel to x-axis or y-axis. That means after the draw the diagram, whatever we get the points intersecting and between the bounded region, we need to take either the parallel to y-axis or parallel to that is a x-axis. That is depend upon our choice. And here, if it is required, then divide the region into two parts. That means sometimes while we are going to take the horizontal, that is a parallel to x-axis or vertical to y-axis, sometimes it is bounded by the two regions. And based upon the bounded two regions, it is a we need to divide what is a divide the two parts depend upon the either the particular parallel to x-axis or parallel to y-axis, then find the solutions individually the two parts and find the limits of inner integral from the strip. While we are going to solving, we need to follow that the condition is from inner to outer, not outer to inner. We need to strictly follow to inner to outer. And here find the limits of outer integral from the axis. That is the meaning of here. We need to identify the region. In that we need to follow from inner to outer. In that we need to find out what is the inner strip, what is the outer strip. And here calculate the examples as the examples of the double integration. Now we need to discuss the problem. For example, you need to understand this is the diagram. For example, it is a bounded region. And here clearly these are some certain the inner to outer. Here you need to observe that. If we take a strip parallel to x-axis, that parallel to x-axis is nothing but when you draw the diagram and in that bounded region, if you mention that like horizontal, that is a meaning of parallel to x-axis. And similarly, it is a what is the x is equal to c of y. That means when you are going to take that parallel to that is a x-axis, the inner is the left side, the outer is the right side. And here the inner parallel curve is a that is left side is a x is equal to c of y. The outer curve is a x is equal to that is a h of y. Next further you need to take that y limits. And y limits is nothing but based upon in this diagram. The y limits are in this that is a what about the inside of the lowest one and again what about the upper one. That means here in this one y is equal to c is the lower point and again y is equal to d is the upper point. This is the clear information parallel to x-axis. And after identification all these things, we need to find the solution. For example, here this is the conclusion of x is equal to c of y, x is equal to h of y, and y is equal to c to d. The conclusion of this one, first integrating with respect to x and again with respect to that is a y, upper limit is that is inner to outer, and again y is equal to c and again y is equal to d. And based upon this understanding, clearly we need to integrate it with respect to x and y. For example, the limits are parallel to y-axis. What is the meaning of this one? The parallel to x-axis is nothing but as we discussed in the previous one, that is a left to right. in the boundary region, but it is a parallel to y-axis. That means here in the vertical axis. In that, if it is a, this is the boundary region, and parallel to y-axis is nothing but it is clearly shown in the diagram. And in this, the lower part is the below side, that is y is equal to g of x. The outer part is above the part, that is h of x, that is y is equal to h of x is a part of the value. And what about the remaining x limits? The x limits are, it is from left side, that is x is equal to a, and again the right side, that is x is equal to b is the point. And based upon this one, we need to do the problem, but is according to, that is the meaning of here. Here x y is equal to g of x, and again with respect to that upper limit is y is equal to h of x, and again the lower limit is x is equal to a, the left side, and again the right side is that x is equal to b is the out value. That means if it is going to consider parallel to y-axis, first what is the y value in terms of x, that is a vertical step, and again after the simplification with respect to dx, that is a clear process that we need to understand. And what is the meaning of division? That is also we need to understand. The division is nothing but, for example, if you draw the diagram of these are the two circles, for example, and in this the boundary region is whatever it is shaded. Here, if you are going to understand in this one, for example, it is a parallel to x-axis. Parallel to x-axis is nothing but there is no division parts because of the left side and our right side. Here, totally the left side is nothing but right side of the circle. The right side is a curve is a left side of the circle. Therefore, based upon this one, it is a parallel to x-axis. Nothing to worry. We are not facing any problem. And such type of this one, for example, parallel to y-axis. And in this parallel to y-axis, while we are going to take that lower strip is on the x-axis, the upper part is depend upon the two circles. One is the right circle and again another one is a left circle. That means it is not possible to find it in the single integration parallel to y-axis. And based upon that, what we need to do that? That means it is a symmetrically we need to take the two regions, one is R1 and other one is R2. While we are going to dividing in like the two sub-regions, we need to find out what is R1 first, and after that simplification with respect to R1, then we need to find out what is R2 is the position. And based upon that getting that R1 and R2, we need to integrating additions. The final solution it will be, that is a solution. For example here also. It is a diagram of the boundary region is the shaded, and again here also that boundary region is when we are going to take that according to parallel to y-axis, it is nothing to worry because of always it is lowest piece on the below line, the upper curve is above the line. But while we are going to take that according to the horizontal step, and here the two parts we are facing the problem. One is from 0 0, that 0 to 2 and 0 to 2. Here it is two parts. One is the lower limit is according to that horizontal step. The left side is on the one is on the y-axis. The right side is the lower line, and again other curve is that one is a lower is based upon the line, and again the other one is parallel to y-axis. Therefore, such type of this one here also the parallel to x-axis it is not possible to within a single integration. While we are going to do that, here also the lower part is R1, the upper part is R2. We need to do that integrating the two parts one by one. After finding that R1 and R2, we need to addition of R1 and R2. That is a final solution of the problem. For example, we need to discuss one problem. The problem is under here the double integration e power of 2x plus 3 into dx dy. Our concept is we need to understand properly what we want to do that. That means the problem is not at all directly limits constants, not at all given the variables. Here given the equations. That means based upon the finding the area region. Therefore, we need to draw the diagram with the help of the given equations. Based upon this one, after draw the diagram, here x plus y is equal to 1. The diagram should be, it is a line. This is the meaning of it is a x plus y is equal to 1. And again x is equal to 0 and y is equal to 0 is nothing but that is on the origin. And while we are going to draw the diagram, you obtain like this. And in this, here the bounded region is nothing but that 0, 0, 1, 0 and 0, 1. And in this one, we need to follow that any order that is depend upon our calculation. Either we need to follow the parallel to y-axis or parallel to x-axis. For example, under the parallel to x-axis. And here inner part is on the y-axis, that means y is equal to 0. And again the right side, what is the right side? Sorry, x is equal to 0 on the left side. The right side is on that line x plus y is equal to 1. That means the limits are, the second one is upper limit is x is equal to, that is 1 minus y, because now x plus y is equal to 1, but we require the horizontal, that means we need to find out that x limits in terms of y, that is x is equal to 0 to 1 minus y. And similarly, first we, after finding the limits like this, that is x, and again the limits are with respect to y, that means lower to outer. And again here after the simplification we obtain the solution. Either if it is a vertical, also we need to follow that y is equal to 0 to, that is a 1 minus x, that depend upon our choice. If it is a vertical, then integrating with respect to y, that based upon the previous concept of after finding the given the limits are in terms of xy, we need to y and again x, and again the lower limit is x equal to 0 to 1, and again we need to find the integration, the solution. Like by solving any like parallel to y-axis and x-axis, we obtain the solution is, it is a like any conditions, we get the same solution. For example, here also, while we draw the diagram, one is a parabola, other one is a line. Therefore, here also the problems. Here the diagram, it should be, it is a parallel, and again that other one is x line. Either we need to take the parallel to y-axis or parallel to x-axis. We need to, according to the limits are, the y is equal to x square to upper limit is a x, and again the lower limit is x is equal to 0 to 1. While we are going to second one, that parallel to x-axis means x is equal to y, lower limit, the outer limit is x is equal to root y, and y limits are the rest of the values from 0 to 1. The solution will be no change. Same, the parallel to x-axis, parallel to y-axis. Here the problem is based upon the two curves are based upon the parabolas. The diagram should be clearly, while we are going to observing here, the diagram should be y square equal to 4x is the parabola symmetrically y-axis, and again the x square equal to 4y is the parabola above the y-axis. Here by taking any order, we parallel to y-axis or parallel to x-axis, we get the same solutions. That depend upon our choice, we need to assume and find the solutions. And next one, polar coordinates. What is the meaning of polar coordinates? Here before going, that is a polar coordinates are under the r comma theta. Then based upon the r comma theta, we need to find the solutions. Here first with respect to, if it is a theta is given, then we need to integrate with respect to r. If it is the limits are r, then integrating with respect to theta. For example, already we discussed in the previous classes. Here the limits are in terms of theta means that r is equal to, and rest of the limits are theta is equal to minus pi by 2. It is a clearly correct form only. We need to find the integrations. Yeah, and again further cos cube theta, then based upon the integrating formula, we obtain that 2 by 3 into 1. That is m is even and n is even, like that based upon the concept. We need to find the solutions. And here also the limits are in r theta, that is r is equal to and theta is equal to. Here also in the correct form. Like it is also generally the indirectly it is treated as under the variables x comma y, but it is also that r comma theta, but these are called as a polar coordinates. R square by 2, and again here sin square theta. That sin square theta, as you know that it is a sin square theta is nothing but 1 minus cos 2 theta by 2, and based upon the formula we need to replace. Here it is. And again here also, after that 1 by 2 take out common, 1 integration is theta minus cos theta integration is sin 2 theta by 2. The integrations upper and lower, the value it will be, that is a pi by 4. That our choice, it is the limits are theta equal to 0 to pi by 4. The condition is r square by 2, and again 1 2, and again here also 1 integration is theta, that means that is a pi by 4 upper and lower, that is a pi by 8 is a final solution. For example, if the limits are not at polar coordinates, that means the limits are under the over the region, that means under the polar coordinates r comma theta, they are not given the limits, then how to draw the diagram? That means we need to understand some of the diagrams, what is under the polar coordinates, what is the structure of the circle, what is the structure of the chordoid, what is the structure of the lemniscate, and again what type of the equations like parallel to x-axis or parallel to y-axis. For example, we need to hear under these are the basic concept, that is under the x comma y, that x is nothing but it is a condition is r, and again the theta, that is angle in between x comma y, that is a theta. And if you need to remember this one, then easy to survive any problem given, and based upon that equations are given, then how to find the solutions, that we need to understand. That is step to parallel to x-axis and parallel to y-axis, and these are the under the polar coordinates we need to remember. Equation of the circle under the polar coordinates, we need to remember or recall. Circle of that generally with radius is a and center is 0 comma 0, and again similarly r is equal to a into cos theta with radius is a by 2, and the circle center is a by 2 comma 0. The circle is in the form of according to not, whereas in the previous that is r is equal to a, that is passing through the origin, but it is not passing through the origin. And similarly a into sin theta, that means left side of the circle of the region, that is above the side of the region. Like equation of the chordoid, that means it is a heart shape, that is a symbolical, that is a 1 plus cos theta, that means parallel to y-axis, that is symmetrically about the right side. That is based upon this one, we need to get like this. Here center and the equation of the chordoid, that is opposite of the right side, that means left side. Radius is, and again similarly r is equal to a into 1 plus sin theta, that means chordoid is above the x-axis, that is symmetrical about the y on the y-axis. And 1 minus sin theta, for example, that means the below side of the x-axis, that is opposite of the a into 1 plus sin theta. And similarly we need to understand what is the lemniscate, that means the equation is such type of r square is equal to a square cos 2 theta, that means the structure is clearly based upon infinity, intersecting according to these are the conditions, that points are intersecting. And for example, a square is equal to a square into r square is equal to a square into sin 2 theta, that means symmetrically on the infinity above the right side. And based upon, for example, we need to understand this problem, r is equal to and r is equal to 4. The structure of r is equal to, as we know that the structure in the previously we shown the diagram, that is r is equal to is passing through the region, the passing through the origin, that is radius is 2. But here passing through the origin, the radius is 2, therefore with the help of the radius is 2. And one other r is equal to 4, that means passing through the origin, and moreover that is a center is a 0 0, the radius is a 4. And here, but here in between these two, the bounded region is in between 2 to 4, r is equal to 2 to 4 bounded region. And in between bounded region, here the problem is first quadrant, that means we need to consider only the above right side of the first region. And here we need to understand what is the inner to what is the outer. And inner is nothing but it is a inner. The outer is this is the outer. That means R is equal to 2 to 4. 2 to 4. It is clearly. And theta. The theta is nothing but the angle in between the covered the boundary region in the first quadrant. That means that is 0 to pi by 2. Because of that is 0 to under here that is 0 to that is a pi by 2. That is the first quadrant. That's clearly 0. That is on the real axis 0 and pi by 2. That means upper is a pi by 2. That means bounded region in the angle from here to it is a covered. That is up to pi by 2 only. And after that, as we know that how to find the integrating with respect to r comma theta, then we get the solution is like that. And for example, the problem is like this. That means r is equal to a into 1 plus cos theta. We need to recall what is the structure of the r is equal to a into 1 plus cos theta. That means the right side of the structure, cardioid. As we shown in already picture, that is called r into a into 1 plus cos theta. And initial line, that means on the initial line. While we are going to observing, that is the bounded region is above the initial line. That means upper part only it is a covered. And here, again we need to identify what is the bounded region. It is the lower part and inner part. The lower part is on the 0. The upper part is on the cardioid. That means 0 to a plus 1 plus cos theta. And the angle between the covering is from the right to that is a lower. That means angle is from here to it is a up to here it is a pi by 2 and it is a pi is a value. That means from here that is r is a 0 and again that a into 1 plus cos theta is a like upper and theta is equal to 0 the right side. That is the meaning of here starting and again up to here. That's a pi. That means up to covering area. Then as we know that how to find the solutions, we find the solutions. Similarly, same this is also like that, but it is a above the portion, draw the diagram, we get the solution. Same, there is also no change. Yeah. For example, this one, the cardioids like circuits, like related to r is equal to a only. The inner is a 2a cos theta, 2b cos theta. Already mentioned that b is less than a. Therefore, based upon the conditions, we obtain this the totally the negative, including the bounded the circles. It is not mentioned that any first quadrant. Therefore, based upon area included between the circles. That means together from total the circles bounded. Yeah. And next one, the change order of integration. That means that based upon if you understand that is a variable in terms of x and y, we need to change the condition. That means based upon the parallel to x-axis. What we understood here, the change order of integration is nothing but if we need to observe first y in terms of x. And again, the rest of the values are x equals 0 to 4a. First, we need to sketch the diagram based upon the given equations, that is a given curve. And after that, we need to consider the diagram is parallel to y-axis, but we need to change the order that is based upon the horizontal straight. That is the condition is. After that, draw the diagram by using the given equations. Here, we obtain the diagram is according to this is the diagram. Actually, it is a parallel to y-axis, nothing but bounded region is in between. These are the bounded region, but the problem is given vertical. That is given the point is vertical because of y in terms of x. But we need to change the order. That means parallel to x-axis. While we are changing to x-axis. Here, inner part is left side, the outer part is the outside. It is the inner part, it is the outer part. The inner part is parabola, the outer part is also other parabola. The inner part parabola is a x equal to y square by 4a. The outer parabola is a 2 root a. And after that, we know that how to find the solution with respect to x and y, then find the solution. It is solution is 16 into a square by 3 is the solution. And here also the problem is change the order. That means the given equation is in the form of circle because of it is y is equal to 0 to root of 1 minus x square and x is equal to 0 to 1. That means it is a circle is given, and under the circle it is a first quadrant only given that because of 0 to root of 1 minus x square. 0 is a lower is a minimum and outer is a maximum. That is the meaning of that is a upper portion only it is covered here. And in this given only vertical is given, but we need to consider what is a horizontal. That means we avoid that vertical. Given that y, we need to change that it is a horizontal. And here lower step is on the y axis. That means x is equal to 0. It is a x. It is a outer is a that is a circle. After the simplification, we obtain that pi by 16 the final solution. And next one, the under the triple integration. The triple integration is nothing but the limits are under the like three integrations. The limits are constants. Similarly, here also whatever we discuss now that is under the double integration, same here also the triple integration. That depend upon our choice. That is R cube is under the region. Here inner to outer. That is the meaning of inner to outer. That is a triple integration. Here it is a first x and y and z. Other is y, x, z. That is based upon the limits are under the constant limits. If they are not mentioned that particularly, like that according to assume x, y, z, first integrating with respect to x and after with respect to y and again after with respect to z. Then we get the final solution. And sometimes first is z and after that simplification with respect to x and with respect to y. Then we get the final solutions. For example, the problem is like based upon the double integration here also. That is the first is z and again second one is y and again x is equal to minus 1 to 1. The solution it will be clearly if you understand the double integration constants, the way under the triple integration also we are not facing any problem, then easy to get the solutions. That is it, integration. Like after that with respect to y, then with respect to integration by replacement of upper and lower. Here after the simplification, again we need to further with respect to x. Again you need to replace lower and upper. The value it will be minus 6. And similarly, this is also one problem under the triple integrations. Here we need to assume that is the first is z, second is y, third one is x. Integrating with respect to z after replacement of conditions with respect to y, with respect to like x. Here after take out common abc by 3, a square plus b square plus c square. And further, the limits are z is equal to y is equal to x is equal to. We need to find them with respect to z, replace upper and lower, and again with respect to y, we need to replace y limits. Here integrating with respect to x and again find the solutions. That is a clear solution. For example, the limits are not given under the triple integrations. That means it is a variable. Then how to find the solutions? Sometimes the limits are not given the variables also. Then we need to find the variables and find the solutions. For example, it is a under the triple integration. But here the problem is that x comma y. Actually, the with respect to x comma y comma z, the limits are given x y. That means we need to assume these are the z and these are the y and these are x. Therefore, by assumption this one, integration z, that is z square by 2, and again replace 0 to 1 minus x minus y, and upper limit with respect to again that with respect to y, the integration as we know that based upon the standard formula. Here the integration is, and we need to replace at y is equal to 1 minus x. The upper limit is, it is 0, lower limit is 1 minus x. And once again, after the simplification, here also grouping method, that is 1 minus x whole power of 4 by 4, it is division by minus 1, and already existed minus 1, then we get the solution. After replacement of 1 by 1 the values, the solution it will be 1 by 24. And similarly, for example, here like z is equal to, we need to assume, and after that replace upper and lower, and again further we need to integrate with respect to y and again x, and finally we obtain the solution is, that is e minus 5 by 2 is a final solution. After with respect to y and x and replacement of y limits and x limits, we get the solutions. Here also the thing is the solution it will be 0 clearly based upon the problem. The function is a, it is a odd functions, the internal value is 0. But here we need to remember minus LDL, the f of x is into dx is equal to 0, since f of x is odd function. Odd functions, as we know the integration form. Yeah, for similarly, like any examples are given, we need to find the solutions. Like these are the clear topics under the double and triple integration. Whenever the limits are the constants and variable, and change the order of integration, polar coordinates, and if they are not given the like variables or limits values, then how to find the limits. And under the triple integration also, the limits are constants and variable, and sometimes the variables are also, limits are also not given. How to find the limits based upon the concept and based upon the parallel to x-axis and parallel to y-axis, we understood properly under the double and triple integration. These are the clear problems and clear concept which is occurring under the multiple integrals. And further any clarifications we need to give, please give the reply for below the link. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.